Hello everyone. Today's presentation is about QDM CLOUD, a new offering from Dimensional Control Systems. It's a cloud-based quality data sharing system. So today, the presenters, myself, Thagu Vivek. I'm the QDM product manager for the QDM suite of products at Dimensional Control Systems. I'm joined today with Rishi Rughootputh, who is the QDM application engineer, and he's in charge for all the QDM products and supporting their applications. So let's talk about the QDM cloud system. Many of you are familiar with the QDM web portal that are installed on site. That's one configuration. We have another configuration where we have a secure hosted server of the QDM web. This is hosted on a secure web platform. This allows suppliers and plans and anybody who wants to upload or contribute data or documents to the system. They use the QDM web portal to upload the data in its native format to the QDM web cloud server. Once the data is stored in the QDM cloud server, all the users can, whether quality engineers, managers, and corporate quality departments, can access this data using a web browser anywhere using the secure QDM web portal. So let's look at some of the benefits of QDM web cloud. The primary benefits are it enables multiple organizations to connect and share quality data via a secure hosted portal. All you need for accessing the data is a web browser. There is absolutely no softwares downloaded to your PCs. Hence, it can be used on, it can be viewed on laptops, tablet PCs, or even mobile devices. QDM Web Cloud is configurable to each organization needs. Everybody's got their own unique needs of how they would like to see and share the data. QDM Web Cloud is fully configurable to each of your organizational needs. QDM Web Cloud is ready to use. It's already launched and hosted on the server. There's no setup required. So that means we can start and go live, starting uploading and viewing your quality data instantaneously. QDM Web Cloud allows for a very flexible licensing method, a subscription-based licensing. It allows you to scale your solution or scale the usage of the QDM web based on your organizational needs. And as your needs change, you can increase or optimize the licensing of the QDM Web Cloud portal. It's a very secure network that's hosted on a dual layers of authentication. It also provides, we also have user level access. Each user has unique username passwords with dual authentications for accessing the data, and every user has a configurable portal of what data they can be allowed to see and what data privileges they have. So this security allows the cloud-based system an ideal solution for sharing your quality information via a QDM web cloud portal. So with that, an ideal use case for QDM Web Cloud is supplier quality data coordination. It allows to onboard suppliers very rapidly and provide a collaborative, secure environment to streamline the quality data sharing process. Today, in today's session, we're going to see a few use cases of the supplier data quality data coordination. So with that background, today's focus is going to be on three functions of the QDM web. How does the supplier quality interfaces work within the QDM? There are three components of supplier quality interfaces which are primarily used. There are multiple ways people have figured out ways to use with suppliers, but our customers. But the three primary topics are: one, how do we manage supplier data? This is inspection data coming from different devices. How do we manage that? Being offline, being in two different networks and being remote in two different geographic locations, how can we manage this without a streamlined approach to do that? supplier quality document management. How do we manage documents? Because documents are an integral part of any process. We can't just stop at the data. There are documents that need to be integrally be a part of the inspections that need to be managed also. So that's the supplier quality document management function that we'll review today. And also a very common topic between when we talk about OEM and suppliers, or suppliers and their suppliers, there is always a negotiation that goes on when a design is submitted to them and they make the process. Their process may not fit, or they might have to make process adjustments. Tolerance concessions need to be provided. So there's a wide range of activity that happens between an SQA, a supplier quality engineer, and the supplier's contact itself. And those tolerance negotiation sessions, we have a tool inbuilt within QDM that can handle that very efficiently, which is a huge plus with the system. So we're going to talk about those three topics today. So first, let's start with the data management. But before that, just for this three exercise, we kind of set up like we want to emulate a situation where there is an OEM and there is a supplier making some parts, and OEM is assembling them and measuring them. So we kind of created a example, a use case here with the OEM being in Detroit, who makes the headlamp assembly, which has got a headlamp, turn lamp, and a bracket, and they assemble that. And then the headlamp, turn lamp, and the bracket, the three components are coming from two suppliers. Supplier A is making, from Windsor, Canada, is making the brackets, and supplier B is making the headlamp and the turn lamp. Just to give you the use case of it, of the whole premise for the rest of the presentation. Just to identify that these are three disparate locations, and there are different, everything within QDM is securely, the data is very secure. Data security model is basically based on the user. So as we kind of registered three users on the system: Sam from the OEM side, Andy from supplier A, and Bob from supplier B. And you will see as we progress through the presentation, when everybody logs in, how their data is so compartmentalized that they can't see anybody else's data, which is very, very critical when you have a central system with OEMs and hundreds of suppliers. The data integrity and the data demarcations need to be maintained, and that's inbuilt within QDM Web, and we'll see that as we progress through the presentation. So this is kind of the use case that we have set up, and with this we'll log in as Sam OEM and do some activities, log in as Andy supplier, Rishi, who is physically in Windsor, Canada for this presentation. That's where he lives. So we kind of emulated that. So he's going to be Andy, the supplier, and interacting with the system. And I from here will be Sam, the OEM, and we'll also kind of do some interfaces with Bob. So we'll do those so you get the picture of how multiple suppliers can interact with the system, being remote in from their own location. So with that basis, let's first start with supplier quality data management. So this is about all the dimensional data, all the engineering data that's part-based, the features, the measurements, the tolerances, the GD&Ts, and all those dimensional measurements. How do we get that data and present it from the supplier to the OEM, or from supplier to their sub-suppliers? So just to kind of create a flow chart, because these are two different geographical locations, we'll kind of go through a flow, and then we'll kind of go into the software and look at those situations. So first is the measurement plan, which is designed by the OEM. So OEM decides what, on a particular component, let's say a bracket, what are the features that need to be measured, what should be the naming conventions for those points. That's decided as a measurement roadmap and then provided to the supplier via QDM Web. So think of the blue line in the middle is the QDM Web that connects both the user base. And so now the supplier receives the measurement plan, which is the roadmap, and also a CMM point file, which is kind of an electronic format that they can take it and create their measurement routines within whatever CMM that whatever measuring equipment that they have at their disposal. Could be any tool, a scanner, CMM, or handheld gauge, or whatever they are, they can write the routine based on the measurement plan and the CMM point file provided by the OEM. Then they use that measurement routine to measure the samples. Let's say they do a 6-piece study or a 30-piece study on the parts. And in its native format, whatever the software that they're using, they can upload those results. They can upload those measurement results back into using QDM Web to the OEM. At the OEM side, the data is validated. As the data is uploaded, because the measurement plan was provided to them via QDM, QDM can validate that data against the measurement plan and make sure all the features that are requested from the supplier to be measured, and all those naming conventions are maintained, so that when the data comes back in, it can be directly consumed without any type of post-processing involved. So all those translation and validation happens as they upload the data, and notifications are sent to the corresponding stakeholders if there is something missing. Once the data is validated, now the OEM has the ability to go into QDM Web and review that report in a graphical format, not just text-based. It's a graphical report because of the templates with all statistics and pass-fail criteria, and they could review it and approve it. And once it's approved, they could send the notification via QDM Web to fabricate and ship the parts, or it's approved, go ahead and process the rest of the samples. So we're going to kind of take we're going to go back and forth between PowerPoint and software to kind of look at this first use case here. So first, let's look at a measurement plan. So measurement plan is and CMM point file are uploaded. So let's, I'm going to escape. So we're going to look at step 1 and 2 of the supplier quality management, which is measurement plan and the supplier receiving an email saying there is a measurement point plan and a CMM point file being uploaded for measurement. So let me escape out of the presentation here, go to my QDM Web portal. So this is a website. I'm just going to my Google Chrome and going to this URL. And I'm going to log in as Sam, the OEM, because I am, I'm going to log in as Sam. Everybody's get a unique username and password. So each user has their own profile managed within the system. Their preferences, color schemes, their different favorites, and all their whatever they are managing, everything is brought directly to the screen. So this is the initial screen that QDM takes the user to, which is the navigation screen, which is configurable, but kind of takes you to this screen. And right now we're going to look at a bracket. So this, for this particular engineer, let's say he is in charge for, Sam is in charge for these 5 components. He could have them in their favorites and quickly look at how the statistics for those points are. But right now, I want to go step by step. So we're looking at measurement plan. So we click on that, the bracket link. It automatically fills the data component of it. What company is this part belongs to? What is the product type? What plant or what supplier is making this part? What program that this part belongs to? What is the subsystem this part belongs to, which is the front lighting? And what is the inspection program this particular requirement is for? It's a headlamp bracket using the DCS demo CMM. So these 6 drill down basically can point to any inspection program within your entire organization. It could be thousands and thousands of inspection programs, but all you need to know is to know the data source, which is the company, product type, plant, and program, which is a one link that you can select, and then the subsystem, and then the inspection program. So these 3 clicks will get you to any bill of material or any part number within your entire organization to see what standard reports are available, how much data is available, and what type of reports you can generate with it. So it's a one-stop shop for your inspection program once you know the inspection program number, or you know these 3 drill downs to get to it. So at this point, I want to review there are 2 files that the OEM has uploaded. One is the bracket measurement plan. So I'm going to click on that so I could see that. So this is a measurement roadmap that was uploaded to say where the measurements need to happen, what should be the name of those measurements and the location of the measurements on the bracket in a graphical roadmap format. So it's easy for the supplier to understand and translate this into an inspection routine. So it's a multi-page report, primarily showing a roadmap of where the measurements need to happen, a balloon drawing, but it's got a little bit more information as far as what should be the position of measurement, what is the direction that they need to be measured, and what's the name. Yes, it's good. It gives them a visual, but anytime they need to create a CMM file or an inspection routine from that, they don't have to manually type these values into the CMM program. We also provide a CMM point file. A CMM point file is nothing but an electronic format of that same roadmap, which provides the name, the location, the vector, and the upper and lower spec, and what type of feature it is, and all those information. So a lot of inspection software has the ability to read in a CSV file and generate their inspection routine. So QDM can also be used as a conduit to provide that. We have a method to export a CMM point file out of a measurement plan and also attach it as a document sent to the supplier. So once these two, as a SAM, me as an OEM, uploaded these two files into the system, then basically the supplier who's slated to, or who is being contracted to manufacture this part, will get a notification by saying, let me make it big again, sorry. So the document name, the measurement plan, what is the data source, what is the subsystem, what's the inspection program, and so this document has been uploaded and waiting for them to review. So this component now is being sent as an email and a text to the supplier contact. So now we go to the next part of that loop, which is now the supplier needs to measure these and use this measurement routine, measure the samples, and upload the measurement results. For this, I'm going to transfer this to Rishi from the Windsor plant, who's a supplier making the bracket part. So I'm going to transfer that so that he will demonstrate how they would upload the data once the measurement happens and how it comes back to me and their interface. So I'm going to go to make another attendee a presenter, and make Rishi as the presenter. So Rishi, I made you the presenter.
Okay, thanks Thagu. So here I'm back on the QDM login screen. So I will put in my username and password and sign in. And as the supplier, like Thagu mentioned earlier, I can only see the part that I'm responsible for, that OEM. So I don't see any other data than my part. So I will click on that and load that data. So Thagu uploaded the CMM point file and the bracket measurement plan as the OEM. So I would download that as the supplier and create my CMM inspection program and measure the 6-piece samples. And having done that, now I will go and upload those 6-piece sample for SAM OEM to review. So I'll go to database, direct data upload, and select the part that I'm uploading the data for, which is the bracket. Here I will only have one option because that's the only part that I'm responsible for. And I'll go and pick that file output from the CMM machine, the 6-piece for the bracket. And I'll just click file upload. And here I can go to data pool session list here. And this will take me to a window, to a new page where I can search for that part and between the date to check if the data was correctly uploaded. And as you can see, the 6 of 6 pieces, samples that I uploaded have been passed. So that's confirmation that the data was uploaded successfully. So from here, I think Sam OEM would get an email notifying him that these samples have been uploaded. So with that, I'll pass it back to Thagu.
You can also, Rishi, click on the headlamp data bracket in the first line just to validate the number of features that was read and number of features that was loaded. So you could make sure that all the 73 features for all the 6 samples were transferred to the OEM.
That's right, and validate the JSON number or anything like that.
Yes. Okay, so now I received a notification that these files are available. So now I'm going to, as an OEM, I'm going to go to step number. So step number 5 is done, which is the supplier logs in and directly uploaded in its native format. And now I am, oh, I didn't, is my screen visible? Supplier quality data management.
Yes, received.
All right, so now I'm going to step number 6. The data is validated. So I can, so I'm going to escape out of this. So we'll do these 3 steps here from the OEM side. Review the data pull session, and we'll review and approve the part itself for the capability and the process statistics. I'm going to escape out of here, go back to the QDM. I'm already logged in. I'm going to go back to the bracket demo, and so now it was 28 samples. Now I see 34 samples. I'm going to take the last 6 samples for this front light bracket that was recently uploaded. Select data. So I'm going to select the last 6 samples, and I am going to run a report with the last 6 samples supplied by the supplier that I got a notification on. So I'm going to generate a report. So at this point, it's going to take the template created for the bracket and the last 6 samples uploaded by the supplier, merge those 2, and create a report with the last 6 samples in a graphical format, showing me the data and all the statistics. So very quickly, we could see what passed, what failed, what fell in the yellow or the borderline statistics, and review the entire report. Whenever there is an issue with any one of the parts, I see some yellow borderline points here. I could click on that particular thing. That's why it's an interactive session for me to analyze the data. I can look at just that one feature, the turn lamp PD, what is happening, why, if any data that I wanted to query further, I can click on that point and it tells me that's trial number 2 that was measured at this date and time. So it gives me that one feature names measurement in a trend chart, run chart, process distribution chart, and also a process control chart. So I can validate that from a Six Sigma perspective, how stable the process is, and should we allow this, or is there need to be any changes to be made or need to be communicated to the quality engineer at the supplier end. So very easily you could navigate and look at the report. So this is one format of looking at the dimensional data. There are multiple, this is graphical way. There are multiple ways that we can look at the data. I'll just pick a couple just for this particular example. The same 6-piece study, so I'm going to do this. So same 6-piece study can be reported as, let me look at different, maybe a data carpet. Data carpet is more, I wanted to see those physical 6 samples in like an Excel-based file with color-coded pass-fail criteria. So then I generate a report. So the same 6 samples, but the presentation or the way the report is being generated is in a different flavor. Sometimes this is required when you're analyzing the data. Yes, graphical gives you a pass-fail criteria, but sometime you might want to look at it as the physical numbers to see what those physical measurements are. So this is another format of looking at the data, which is characteristic, the 6 measurements, the deviation of each measurement for each feature, and how the statistics are, CP, CPK, and X bar, what fell in the green zone, what features fell in the red zone or yellow zone, nothing red here. And then a kind of a summary of how many points are within the CP and CPK of different flavors, of different zones, if you want. So that's another way of looking at the same data. Maybe the engineer would like to see more from CP, CPK zone, which would be how many points are within a certain CP and CPK zone. So maybe it's right now you're only interested in process capability. So now this is another way of looking at exactly the same 6 samples that was uploaded by the supplier to see 84.93% of the data came with a CP of greater than 1.33. This 15% of data came with, which is 11 features, came with a CP of 1 to 1.33, and there is nothing below it. So it means everything is only in the yellow or in the green zone. So and also quickly see a table of that below. So these are all different ways of looking at the data depending upon what stage of production you are on. But or you can actually make it an Adobe PDF and then email it to somebody, and you could get a graphical report issued to email that graphical report to anybody in your organization if you save that as a PDF file. So there's interactive reports, graphical reports, there are box plots, tables, summary reports, and every company kind of creates their own little flavor of reporting format that can be added to this, configured and added to the list when we something specific to their flavor that they need. There is also an option to export to 3DCS. Let's say I want to take these 6 samples, or maybe there's 100 samples they uploaded. I want to export this data to 3DCS. It exports it in a format that directly plugs into 3DCS, and now you could rerun the variation simulation, that's a design side, to validate your design based on the supplier parts that are coming in. So that's another benefit of using the QDM web, because of the link between 3DCS and QDM, the direct link. So these are all different flavors of looking at it. So the engineer primarily will look at the results and pass, fail, or whatever decision that the supplier quality engineer would need to make the decisions, and let the and send notification to approve that particular part, to ship the parts or make changes. So that opens up the communication for the corrections or the fix loop that need to happen before they ship the parts. So so basically what we did at this so far, going back to this data management. First, we created a measurement plan. We sent that to, and the CMM point file, and sent it to the supplier. Supplier used those to create those measurement routines and samples, and measured their parts and uploaded the measurement results. Data got validated and uploaded, and then the supplier quality engineer had multiple tools within the system interactively to review and approve. And once it's approved, a notification sent to fabricate and ship parts, or go ahead to move forward. So this concludes at least for this presentation, the overall kind of a 50,000 feet overview of the supplier quality data management, how dimensional data is managed. We just showed you for one part. This can be simultaneously done for hundreds of parts with hundreds of suppliers, because it's a web-based tool, which is basically a shared platform. So typically in any environment, there are hundreds and thousands of the parts where each supplier quality engineer is interfacing with their suppliers and getting this particular loop done within the web system at any point in time. All right, so that now we move to so that's about data management, physical measurements. Now we talk about, there is also a need for documents. There are gate reviews, there are PPAP approvals. If you're in the aerospace, then there's AS 9102, first article inspection reports, gauge certifications, gauge R&Rs, and all those type of documents need also to be maintained as a part for each inspection program. So when I navigate to an inspection program, when anybody navigates to an inspection program, they would also like to see all the relevant as standard reports, not just the measurement plan, the CMM point file, and the report for that for the dimensional inspection, but also the different documents, the PPAP report, the gate approvals, and all those documents all in one place. So anybody who's navigating to it gets access to all those documents a click away of the latest status of them. That is, and it's also managed within the QDM Web product. So that is the document management part that we're going to review now. I'm going to go to the document management workflow. Typically, documents are initiated at the supplier level. So in this particular case, in this use case, let's say supplier created a PPAP document with a 6-piece study, and that's a standard document that may need to be managed for that particular inspection part. So they upload that document for review using QDM Web for that particular bin. So now the SQA at the OEM is notified that there is a document waiting for review. The SQA reviews it. They add sometimes, in this particular case, we're going to say that there are some not okay points or need to be fixed points in that PPAP document. So SQA can add comments and revert that or reject that document. And that rejection notification goes back to the supplier. Now supplier makes those corrections or remeasure it or change their tooling and redo the parts and re-upload another PPAP document. Now SQA is notified. Now SQA can e-sign this document, approve with comments, and now supplier is notified that this document is approved, or they can move to the next phase. Now it's available for all publishers. So the first step 1 through 9 only happens between the supplier interface or the supplier contact person and the SQA at the OEM end. Nobody can see these interactions between 1 through 9 until it's approved, and now the SQA signs it. Now it becomes a published document for anybody who's navigating to that particular inspection program to see it. Until that time, it's only a communication between the two, and the system keeps changing the status of these documents along the way. It could be in pending mode, it could be in review mode, it could be approved. All these different status, but all those are visible only to these two users. So it's very securely managed between two groups, and then until it's approved, now it's available for everybody. So we're going to kind of go through this use case. Just a quick time check. Okay, I might have to speed it up a little bit. So we're going to look at uploading a document, OEM and PPAP trial document. So we're going to do step 1 and 2. Rishi is going to upload a PPAP document, trial 1, from supplier A, and I will log in, and I will get this notification saying there is a document waiting for me, so with a status pending. So let's do that. I'm going to make Rishi the presenter.
Okay, so for me to upload the PPAP document, I will go to Document and Document Mapping, and I'll go to Add. And here I'm uploading the document type is a Excel sheet, and I'll call it PPAP for the bracket. Here will be PPAP for the bracket, and I'll call it revision 1. And here select the data source, the part that I'm uploading, where I want that PPAP document to go to, and I'll select the document for 1. And here I gotta make sure that I click show only to author contact until approved. That makes sure that only me and Sam OEM are able to see it until the document is approved. And here, make sure that SAM OEM is a contact, so they will receive an email when I click submit. So that's the PPAP document uploaded, and I'll transfer back to Thagu.
Okay, so I'm going to show my screen. Just in the interest of time, I get an email saying a document is being uploaded, like what you see on the sample here. Document name, the author who submitted it, Andy, the supplier submitted it. Subsystem is the front lighting for this headlamp bracket, and it also gives me a QDM web document access page with a link. So when I click on the link, it directly takes me to this page with the bracket link. And when I go there, I do see there is a bracket, a PPAP bracket Rev1 document with a status of pending waiting for me. So I can click on the document, download it, show in the folder. I'm going to review that document that was submitted. The 6 piece that was measured and uploaded. So I'm looking at the document price, and I see a few of the items that are not okay. Most of the features are okay, but I do see some bracket holes that are not okay, that came in as not okay. So I cannot approve this document because there are a bunch of not okays on the result. So I am going to click on the pending, and I'm going to attach a note saying remeasure bracket holes and re-upload. So I do that. I'm not going to e-sign. I'll just notify the author of that. And now I'm going to back. So now the document status, so I've already sent a notification to Rishi, and now the document status is in review. So that's, now I'm going to transfer it back to Rishi for him to do his corrections or tool changes, whatever, and remeasure the part and upload the Rev2 document.
Yep, so I go back to document mapping here as I've made the modifications requested by the supplier. And here I'm not going to add a new one. We already created an existing quote unquote bucket for that part. So I will go and find it. And here's the PPAP bracket. And I'll select it. And here I'll call it just the Rev2. And I'll choose my file. PPAP bracket Rev2. Again, everything else looks okay. And I'll just click update. And that should send an email back to SAM OEM that a new revision of the bracket PPAP has been uploaded.
Okay. So now I'm going to my link again. When I click on that, now my PPAP bracket 2 Rev2 is, you see the standard document on my page. When I'm logged in as Sam here, I see the PPAP Rev2, but now it needs another review because there's a new document. So now I'm going to download that file, open that file, and review the new updated document. And in this case, I do see all my results are okay based on my PPAP results. So I can approve this document, and I'm going to go back to this pending and say approved or whatever comment that we need to put, and e-sign on this. So now it's e-signed by me, SAM OEM, for this particular part. And Now the document is approved. Now the status changed to approved. And now this will be available to all the users so anybody who's navigating to headlamp bracket now will be able to click on the PPAP bracket 2. That was the revision 2 that was happened at this date and time and approved by Sam, is available as a click away. So this is just kind of a use case and a flow. So now we talked about 1 and 2. We're looking at 3, which is the SQA reviews it, adding comments and reverting back. Supplier got notified with this email. Let me make it bigger. So now it's in review status, which says document bracket PPAP uploaded at this date, reviewed by Sam OEM and rejected for the following reasons. And the reason was submitted. This all went as an email and a text. So so the supplier is notified, and then the supplier makes the corrections and upload the review document like Rishi did. And now we get another document upload notification saying another document is uploaded and the status is pending. We do the review, e-sign for approval, and once it's approved, another email of document approved and uploaded and approved sent to the supplier, and now it's published for all users and accessible as a standard document. So we kind of quickly went through these steps here. For the document management. So this is kind of a basic use case, but just to get you to that idea of, and could be done for any document, for any data, for any type of features. When we talk about documents, we can take, you can load in HTMLs, PDFs, Excel, CSV file, text files, or any image files. All those type of files can be uploaded as documents and follow the same process for review. So the idea is to keep everything together for that particular inspection program. So when anybody goes to a certain inspection program, when they drill down to an inspection program, because you're going to have thousands of these in your environment, very easily to navigating to that, looking at it, you would know the latest status of documents, the files, and also the reports, all kept in one single location, streamlining the whole quality management process, the QMS system. All right, so now with that, let's go to the last topic for today, which is the tolerance negotiations. So this is a very valuable topic which happens most of the time between a supplier quality engineer and an OEM. So supplier uploads the data. Let's say they do a 30-piece study and upload the data, and the data analysis is done at the OEM. They look at that, but they do see, let's say the SQA finds a few problems that the capability is not meeting the needs. To make it, and the target CP that's for this particular phase is 1.33 or higher, and for some features it's not meeting them, then typically there's a tolerance negotiation session between the supplier and the OEM. It can be initiated at the supplier end or at the OEM end to see, based on our process, these are the tolerances. Can we get some tolerance concession on these points? And we look at the design, and if it doesn't compromise the design, then these type of negotiations are done, and a document is signed for those approved negotiated tolerances, and then now it's published for all the QDM web users. So we have a tool, that kind of a collaboration tool between the two. I'll kind of quickly walk through those steps here. So as an engineer, I'm going to maybe use the turn lamp data that came from supplier B. So turn lamp was made by supplier B, and for the front lighting, and the name of the program is turn lamp. So now I'm going to take the last 30 samples and generate a report. Submitted by the supplier for the turn lamp. And when I'm looking at it, I do see all my points, all my capabilities are green, but I do see one point on this pin where my capability, my CP values failed, and I see some yellow colored ones. Maybe not very visible in your screen, but it is. I can click on it to drill down and then see the details of that. So I'm looking at it, and I see that the capability is a little bit off. CP for those are didn't get up to 1.33. It only got up to 1.2. So there is a little bit of here it came to 1.13 for the Y, and for the Z it came to 1.17. So it didn't make it up to the target of 1.33. So in that particular case, we will initiate a session with the, we export this file out and we initiate a session. So let me go back here and I'm going to pull it into the tolerance negotiation module, this file exported out. Now we're going to have a session with the, now we're having a session with the supplier. Both of us looking at the same report. I put the system in a tolerance negotiation mode, and it's telling me, it's analyzing the entire report based on all these measurements that were done. These are the gray part is based on the current specification. So let me pick this item that was failing. My current specification was ±1, and my CP value that I reach, I'm getting is 1.2, which is failing a target of, I set my target to 1.33, and it's telling me to get to 1.33, you need to open up your tolerance to ±1.1 for this particular feature. And to get to 1.33 on this feature, you need to open up your tolerance to ±1.17. And for this feature, you need to open it up to 1.14. So just to, and this is an interactive, you might want to know where this feature is. So double click on this feature, it'll take you to that page and show you that is the pin that's on this location, and it highlights that chart. So you can see the location of the part. This is a simple part, so it makes it easy. But when you are doing very complex part, this interactivity between the tolerance negotiation tool and the graphical interface is very valuable, because you can kind of, it's an integrated system to kind of click between those two and look at it. So now I'm going to say, okay, we're going to approve these changes, or I can make, let me say, no, we can go up to maybe we can go up to 1.17 here. We can maybe only go up to 1.0. So I'm manually editing these numbers to 1.0 and see what would be my capability. My CP is only going to get up to 1.25. You can agree to it or change or do whatever negotiation. So it's an interactive session between the two, and it's done within one meeting. Once all these tolerances are done, you can apply spec limits, or you can also apply mean shift and then make CPK come in also. So we could we can apply mean shift. So now it all not only applied the spec limits, it also applied the mean shift corrections to get the CPK to 1.33 target also. Once that is all done, we would export, we'll apply the proposed tolerance and export this file as a tolerance negotiation file or a negotiated tolerance file for this particular part. So once that is done, I'm just going to open that file. It exports this out in a format that it is a standard format called proposed manufacturing tolerances. The gray boxes show all the, in an Excel format, it's a form where this shows all the current specification, and this shows all the proposed specification with all the changes, and the dimensional engineer, the product engineer, the quality engineer, supplier engineer makes their name and approves this process by signature. This becomes a standard document. Now moving forward, they could use these approved proposed negotiated tolerances for the part. So this is a standard practice, and we have an integrated tool within QDM to support this workflow of supplier uploading data, OEM analyzing it, and doing a tolerance negotiation session, exporting an approved negotiated tolerance document. Everybody is signing to that, and it becomes a part of the part process for that particular part number. So this can be done for each part and all kept together in the same interface. So that basically is the tolerance negotiation component of it. I will maybe just show this in a nutshell. Basically, review it in a graphical format. Look at the tolerance negotiation. Look where it failed. apply the tolerance negotiation to remove those red failure points, agree on it, and create a proposed manufacturing tolerance document that becomes a part of the standard document for that particular thing. So now we're going to, so I think that concludes the 3 topics that we want to talk. I just want to highlight one thing. When we talk about suppliers, you're not going to have one supplier, you're going to have hundreds of suppliers. The system automatically aligns everything up to a dashboard that this company ABC Inc. contains lighting as the product type. You could have multiple product types. You can have hundreds of or multiple plants. There's one OEM plant and one supplier and one supplier B. Z1 is the program that we are supporting. So it gives you a kind of a quick dashboard of looking at it. And I'd like to know how supplier B is performing. I can click on that and it'll tell me supplier B is performing at 90.35% capability. All the points are in spec, but capability wise, they're at 90.35, meaning 90.35% of the points are coming above the target CPK for what everything supplier B is making. I'd like to know a little bit more. I'm going to click on that. On supplier B, it's saying they're only making one component. If they're making multiple components, I'll get the decomposition of those components and their individual percentage, okay, and the CP and CPK value. In this particular case, they're only making one. So they're at 90.35 on the front lighting. Click on front lighting, but they're making 2 parts for the front lighting. They're making headlamp and turn lamp. Headlamp, they are at 94.74% capability. But on the turn lamp, they're at 94.74, but on the headlamp, they're only at 85.96. Would like to know more about that? You can click on that. Now it takes you to the navigation screen. You can to the headlamp. You can look at the last 10 sample report, kind of review the turn lamp and see where the failures are happening. And most of the failures were happening on this pin right here and this pin right here. So it gives you a kind of a nice top-down view from a dashboard perspective to manage all your suppliers and have a scorecard for each of your suppliers and how they are doing with the parts that they are making for you, all in one easy to navigate and an intuitive interface with a top-down approach. So today we looked at these 3 components of how QDM Web handles supplier quality as a data, all the data that's coming in, the physical measurement data, how we manage document workflow, and we also looked at the tolerance negotiation workflow and a little bit of the dashboard. Maybe we'll do a separate session on the dashboards downstream, but these are primarily the main supplier quality functions in the system.